Yeah, so have you, hi, Rolf, Rolf Brink here. Just a question in my capacity as Immersion project lead. Have you already done any work on liquid cooling technologies besides rear door cooling, as in for immersion, for example, or cold plate?
Um, the way that you would, well, let's just talk about immersion cooling. So an immersion cooling device is going to have a pump in it. The pump is probably going to have a speed controller in it that is based on temperature. It's probably going to have some kind of a heat exchanger that's connected to the facility's water, and you'll have a valve on it that needs to be managed based on probably exhaust temperature on it. And you'll have a number of other sensors that are in there, like coolant temperature, valve position, pump speed. And the Redfish implementation of all of those devices is exactly the same as what you would use for a rear door cooler. There's no difference in managing a fan speed versus managing a pump speed from the Redfish perspective. So what we did within the rear door heat exchanger is a profile just for that. But when we created it, we kept it in mind that it's not the only cooling technology within OCP, and that we didn't do anything in the profile that would preclude it from being expanded to cover any other cooling technology. Within one second. Within the door heat exchanger, there's also some manufacturers on the team that do CDUs, and it's the same kind of thing that you would have inside of a CDU with pumps and valves and sensors. So I don't think that there's anything that's in the profile so far that would restrict it from being expanded to any cooling technology.
So this is John Liang. One of the early work in progresses that we shipped out actually had a response from, I believe, the ASHRAE, who said, well, you're missing all these telemetry data for fluid flow. So they actually added a bunch of telemetry information that types within our model to add fluid flow. So at least we did not want to create a different set of naming. We'd much rather use the ASHRAE's naming if they have a set.
And so with immersion, you're also looking at the new type of thermal domain, right? If looking at the dielectric liquid. So we'll speak as Asperitas now for a second. We've equipped our system with all sorts of sensors to indicate the thermal layering without a tank. Is that something that you can, is it just as easy as just adding a couple of sensors to the grid, or is there more relevance also in trying to interpret it and give it a special meaning?
What are the sensors actually measuring? Just temperature?
Usually just temperature, but we're also talking about water detection, or the liquid level, the level of liquid in the tank, whether it's not too high or it might overflow, right? Because that liquid expands when it gets warm. So these kind of things we find very valuable as Asperitas.
So what I've always found useful in doing new models is to draw a picture so everyone gets on the same page as to what it looks like. Because as I told you, we are not subject matter experts in any of this stuff. And the diagram helps the Redfish modelers kind of understand what they're trying to model. And once we agree on that, then the actual naming of the sensors, we know what to do with them, what they're trying to do. But I've been in meetings where people talk about sensors without having a diagram, and the perception from both sides is just different. And so especially if you have this new domain, draw a picture and let us talk about sensors in relationship to that picture.
So what do I do if I want to contribute in there? You have a call schedule?
Yes, we have a cost schedule. Unfortunately, the Redfish forum is part of DMTF, and DMTF is by membership only. And so what we found is if it's from OCP, that the DMTF has a submission portal where the OCP and other companies can all submit their quote ideas and suggestions through the portal, which basically releases IP. So if we take your suggestion and we implement it somehow, that you can't come back someone later and say, well, I never gave you the IP for it. So I'm going to assert patent on it or particular. So the submission portal is exactly how the control model that the OCP was working on, or effector model, was submitted into DMTF, so we could look at it and we can say, oh, this is close enough. We add a couple more properties to our control, we've got it. So that's what we did, and then we release it as work in progress, so it can become public yet again. And then Michael, who's not part of the DMTF, could actually look at it and say, well, you did it right or you did it wrong. So if you have a wholly new domain, I would, and you want to add sensors and explanation, submit it through the portal. So we can have, we can understand that it's something we can incorporate into a standard without any encumbrances.
Yeah, so just for your information, there's an immersion requirements document, which was published early 2019.
Mm-hmm.
And that also contains a chapter on Redfish and what such a Redfish environment could look like with the angle of immersion specifically.
And we were at that presentation, I think.
No, you were at least not part of the get together of that document.
No,
but,
I think
I hear something to synchronize on here. So let's at least get in touch to make sure that we can synchronize these efforts somehow.
Definitely, and you know, Jeff Otter, I think, might be on the line, but we're open to coming to almost any OCP meeting, right, and having a discussion.
Now, from if you're part of the OCP immersion cooling group, then one of your next steps would be to create a profile for either expanding the profile that I worked on or creating a profile for immersion cooling.
Well, the problem is that you create a profile after you have the sensor elements that you need. And from what I'm hearing, we need to enlarge the schema so we have the sensor elements in order for him to make a prescription that he wants them.
I didn't get that. So he's talking about temperature. So there's a DMTF model for a sensor, and one of the elements in it is like a reading type. So it will tell you whether it's a pressure or temperature or current or voltage or something like that. And if the sensor readings that you need to get out of this management interface already exist, then there's pretty much no work for you to do other than creating a profile that prescribes what the management interface would look like. But if you need a sensor for like pH value and that doesn't exist within the DMTF, then what John was talking about is you can go in through the DMTF portal and you can say, we want to implement cooling in this particular environment, and you don't have a sensor reading for pH or something else that you might need. And they can add it to the next update of the sensor model, and you're good to go. So your best bet would be to either try to create a Redfish implementation of all of the device controls and sensors that you've got. And you could either do that on one of your immersion cooling devices, or there's another thing called a mockup, and it's a set of JSON files with a little bitty Python web server that will pretend it's the cooling interface into your, in your case, your immersion cooling device. And when you poke at it with a web client, it looks just like what your cooling device is going to look like. And I found that highly educational to try to create a model of a device while I was working on understanding the schemas and trying to create a profile all at the same time. And it gave me some really good insight as to what the redfish needs to look like and how to describe or prescribe what the redfish needs to look like. And then going through the redfish specification and finding if the sensor reading types and stuff that you need already exist. And this is how we discovered that the controls didn't exist. So I'm volunteering you for some work if you didn't catch that drift there.
Yeah, sorry, I'm on mute. I'm trying not to take over the session as well,
but it's interesting.
Michael, yeah. I'll send you my OCP address as well. So I think I would really like to be able to sync with you directly as Immersion lead, just to make sure that what we're doing in the Immersion community is going to be aligned with easily aligned with what you guys are doing. And I think some of the suggestions that you're making is exciting work.
Yeah, what I had talked to John about a while ago was the idea of creating a cooling profile, not a door heat exchanger profile. And since I was working in the door heat exchanger group, we contained it to that, which brought the scope down to something that was manageable. But it might actually be a good idea to promote the profile that I started, and maybe your group and the cold plate group and some of the other groups start adding on to it if it's missing anything to become a generic cooling device profile.
I think that sounds great. I think there's a few other people who want to ask questions as well. So
I've got one question. Can you get into a situation where you have controllers fighting to set the values in Redfish is trying, and while there's another overlaid controller over that might go in and try and update the values again? Is that an issue that you've seen, or you think you might run into?
You want to take this, John?
Oh yeah, you set up a situation where a conflict can occur. Probability is it will occur. So it's to me, Redfish is a interface definition and a modeling interface. It is not an implementation, and Redfish tries to be implementation agnostic. So when we define the interface, it's basically the best implementation wins. And so conflict, if the model doesn't allow conflict, if the implementation allows conflict, then that's something that can happen and we can't help.
So my take on that would be, we'll go back to like a water flow valve for the door heat exchanger. So the cooling control loop would be looking at, say, differential water temperature and deciding what the valve position would be, and then setting the percentage of opening for the valve. If you went in through the Redfish interface, and if it happened to be a writable value, and you said, set the valve to 80% open, and then the control loop says, set it to 30% open, and you say, no, I want it 80% open, you'll obviously end up with some conflicts on there. But if you go in and you change a threshold in a sensor, you're not changing, you'll indirectly change what the control valve position would be, but you're not fighting with any of the controller. You're modifying the behavior of the control loop. So you can go in and fiddle with the PID values and the scheme that it's going to use for determining what the valve position is going to be, and temperature set points and things like that. And it won't create any conflict, because it's the control loop itself that's controlling fan speed, pump speed, valve position opening. So you may end up with some behavior that you don't really like. It's using more water than you would expect, or more energy than you would expect. But I wouldn't unless you start trying to manually control something like fan speed that the control loop would normally manage, then you won't end up with conflicts. If you do want to manually control the pump speed or fan speed, that one of the parameters on the control loop is automatic or manual. So you could actually turn off the control loop and manually go in and control fan speed or pump speed. And that's in there so that you can do diagnostics and maintenance on the system. So if you wanted to, purge bubbles out of your loop or something, you may want to open the valve all the way up and turn the pump on full speed. The control loop normally wouldn't let you do that, but if you turn the control loop on to manual, then you can go in and you can directly control the pump and the valve without conflicting with the control loop, because you turn the control loop off.